All right, that last video was really long, so hopefully you made it through it. But now what we're going to do is talk about why all the questions say solve each equation and, if applicable, tell whether the equation is an identity or a contradiction. All of the questions that we did up until now, we got to ignore this sentence because we got a solution. We got x equals 5, x equals 2. What's going to happen now is that when you're solving, something's going to happen that's going to make you go, huh, what? So up until now, every question that we have solved has been true on the condition that x is equal to 3, or x is equal to 4, or x is equal to negative a half. But we've ended up with x equal to something. We've gotten one solution. We can declare it as a solution set. X is equal to something. But now what's going to happen is we're not going to get x is equal to 3 or a half. So let's try some of these questions just to see what does happen, and then we'll determine whether that makes it an identity or a contradiction. So for this first one, if I went to go solve this, the first thing I would do is simplify. I'm going to collect like terms. I have 2x minus x is x. I'm left with x minus 6 is equal to x minus 6. Now, even right here, is that making your spidey senses tingle? Are you like, huh? X minus 6 equals x minus 6. Isn't this the same thing? And even if you didn't notice that, what I would do next is try to get my x's on one side. So whether I minus x to get rid of this one or minus x to get rid of this one, when I put the x's on one side, they actually go away. If I went even further to get the numbers on one side, the numbers go away. I'm left with 0 equal to 0. That's weird. What does that mean? Well, when you end up with 0 equal to 0, or negative 6 equal to negative 6, or even x minus 6 equals x minus 6, this is an identity, right? I think of it like a mirror. You're looking at yourself. 0 is looking at 0. Negative 6 is equal to negative 6. And what that means is that the equation is set up for success. No matter what you put in for x, the equation is going to be true. I mean, if you think about that at this step, right? If I was to put in x is 7, 7 minus 6 is the same as 7 minus 6. No matter what I'm putting in for x, I'm subtracting 6 on both sides. So the answer is going to come out the same, which means there's actually an infinite number of solutions. Any value of x is going to make this equation true. To declare it as a solution set, you can use the set brackets, and you can say the answer is all real numbers for x. This is the shorthand for that. So x is an element of, this is an epsilon symbol. That means is a member of or is an element of. And then r stands for the real number system. So when you end up with zeros disappearing, sorry, not zeros, x's disappearing, and you end up with a true statement. So this is a true statement. 0 equals 0. 5 equals 5. Negative 1 equals negative 1. That means that there's an infinite number of solutions. So x can be anything. Whereas, let's look at this one. Oh, sorry, let's finish that one off. So solve each equation. Okay, I went to go solve it. Something happened. My x's went away. I was left with a true statement. So then I'm going to state that this is an identity. Only when the x's go away and you don't get x is equal to 4 or 5 do you need to state if it's an identity or a contradiction. If you get x is equal to 3, just stop. X is equal to 3, right? What about this one? So first step, let's simplify. I've got 3x minus 2x is x. Now for this one, I'm left with x plus 3 is equal to x plus 4. This isn't feeling like an identity, right? Whatever I take to x on this side, I'm going to add 3. Whatever I put in for x on this side, I'm going to add 4. This is never going to work. And in fact, if I went even further, my x's would go away. I'd be left with 3 is equal to 4. Well, that's not a true statement. If I went even further and I subtracted 3, I would get 0 is equal to 1. It's not a true statement. I get a false, that is not an F. I get a false statement. When you get a false statement, it's called a contradiction. So if you have something like 0 is equal to 5 or 1 is equal to 12, right? And what it means is that there are no solutions. You would show this by putting a null sign. This means no solutions, or not and, or empty set brackets. There's nothing in your set. There is no solutions for this question. So for this one, you would call this one a contradiction. No matter what I put in for x, this equation can never be true. So if your x's ever go away, then you need to state whether it's an identity or a contradiction. If the x's go away and you're left with a true statement, it's an identity, meaning there's an infinite number of solutions. X can be anything is your solution. If the x's go away and you're left with a false statement, it's a contradiction, which means there are no solutions or your set brackets are empty. Whereas if I ask you to solve the question like this one, so I go to put my x's on one side, I end up with 4x minus 3 is equal to negative 3. Then I'm going to add 3 to each side. I end up with 4x. Sometimes my 4's don't look very good. 4x is equal to 0, but my x didn't go away, right? Then I'm going to divide each side by 4. I end up with x is equal to 0. This is not an identity or a contradiction. This is a conditional statement. This equation is true on the condition that x is 0. I do not need to state that it's an identity or a contradiction because it's not one. It's a conditional statement. I got a solution. I'm saying it with so much emphasis because everybody doesn't notice it in their textbook questions. Then all of a sudden on the test, they see this statement, if applicable, tell whether the equation's an identity or a contradiction. And then they think they have to say everything's an identity or contradiction. Excuse me. There's a reason it says if applicable. If applicable, aka you do not get x is equal to 5. Then okay, your x's went away. Are you left with a true statement? It's an identity. Are you left with a false statement? It's a contradiction, right? Infinite solutions, no solutions. Awesome.